This presentation goes with the assignment called Periodic Table Notes. And here we're going to learn how the periodic table can help you determine how many shells or orbitals are in each element and how many valence electrons each element or atom also has. Before that, let's learn about some history of the periodic table. In the late 1800s, Dmitry Mendeleev, who was a Russian chemist, organized his elements by increasing mass. And he found that characteristics such as density, malleability, and ability to react with other elements repeated. So he called it the periodic table, which means a repeating pattern table. In the present day, the elements are arranged by atomic number, which we know goes with the number of protons, and in a neutral atom also the number of electrons. So in the beginning we had Mendeleev, who lived mid-1830s to 1907. Now we have a scientist, Glenn Seaborg, who lived up to 1999. He was so instrumental in adding the new elements, the ones we find with lots and lots of protons in the hundreds. He discovered 8 of these new elements, and he was the only living person for whom an element was named. So if we look at the rows of the periodic table, we see, and our picture here is color-coded to help show, the rows are called periods. The periods determine or tell you how many orbitals or shells each element has for its electrons. So we have 2 elements in the first period. Those are hydrogen and helium. These 2 elements only have 1 electron orbital for their electrons to go in. Elements in the second period, or the second row, have 2 electron orbitals or shells. Elements in the third period have 3, and fourth period have 4, and so on and so on and so on. The elements that are in these periods have the exact same number of electron orbitals or shells. Then if we look at the periodic table going the other direction, if we look at the columns instead, these are called groups, and we know that each group tells us how many electrons are in the outermost shell. These are called valence electrons. So each element in the groups, and we focus only on groups 1 through 8. In some of our previous assignments, you saw these numbered 1 through 18, and that's technically true. However, we kind of ignore, for the purpose of this chemistry course, we're going to ignore the transitions. We're not going to worry about those particular elements. The rules they follow get a little tricky. So each element in group number 1, which is also known as a family, and you learned about this last week, these are the alkali metals, very reactive. These have 1 electron in their outer shell. And remember, as we go down, each element in this column, or each element in this group, would have a different number of shells. So this element would have 1 electron in its outer shell, and it only has 1 shell. This one down here, however, has 2 shells, and in its outermost shell it would have 1 electron. And then we go across from left to right of the periodic table. So group 2 elements, the alkaline earth metals, they have 2 electrons in their outer shell. Then we have group 3, 4, 5, 6, 7, and 8. Group 8 is the special group because they have a full outer shell. And again, these electrons in the outermost shell are called valence electrons. The one exception to group 8 is helium. It only has 1 shell. And since it only has 1 shell because it's in the first period, that outer shell is still full, but it can't be full with 8 electrons because the first shell can only hold 2 electrons. So it still has a full outer shell, but it is full with 2 electrons instead of 8. Another term that you need to know is the kernel. This is everything in the atom except for that outer shell, or the valence shell. The kernel includes the protons and the neutrons in the nucleus, and all of the shells up to the last one. So there is a maximum number of electrons each shell can hold. In the first shell, the maximum number of electrons we can have is 2. In the second shell, we can have 8. In the third shell, we can have 8. In the fourth shell, we can have 8. Then we have this other group, which includes the transition metals, the lanthanides, and the actinides. Transition metals have slightly different rules for shells and valence electrons. And this is something we'll save for, future chemistry courses. So if we look at a periodic table and we need to know the number of shells and number of valence electrons for carbon, carbon's in the second period, so it has 2 shells, meaning it's in the second row, and it's in the fourth group, so it has 4 valence electrons. So it would look like this. Sodium, on the other hand, is in the third period, so it has 3 electron orbitals or shells, but it's in the first group, so it only has 1 valence electron. So sodium is going to look like this. We have 3 shells, and in our first shell the maximum number is 2, in the second shell the maximum number is 8, and in the third shell the maximum number is 8 again. But this only has 1 in that last shell. So your job is to take a look at your periodic table, and using the information that we have just come up with, you're going to write your answers on the handout. So first, your job is to name this element. What is Ne? How many shells does it have, and how many valence electrons does it have? This is neon. It's in the second period, so it has 2 shells. It's in the 8th group, one of our noble gases, so it has 8 valence electrons. And would look like this. 2 shells. The first shell, the inside shells are always filled, and then the outside shell, or the valence shell, has however many valence electrons that particular element would show. Our next element is H. This is hydrogen. It's in the first period, so it has 1 shell and 1 valence electron. Hydrogen looks like this. Our next element is beryllium. It has 2 shells and 2 valence electrons. So if we think about this element, the inner shell is full, and we say full is always happy. But the outer shell can hold 8. So for beryllium to truly be a happy element, it's got to have 6 more electrons. It's going to get those electrons by bonding with other elements that have extra ones to give. We'll talk about that in our next assignment. Our next element is sulfur. Sulfur would have 3 shells and 6 valence electrons. And then we have potassium. This has 4 shells and 1 valence electron. And helium. This would have 1 shell and 2 valence electrons. Helium, as you know, is the exception in group 8. Group 8 are the noble gases. Since it only has 1 shell, that shell can only fit 2 electrons instead of 8. It's in this group because its outer shell, or its valence shell, is full. Very good. If there are any questions, make sure you understand how to do this, and make sure you could pick out an element on the periodic table and figure out how many shells and electrons it would have. That's going to be key for understanding the other 3 assignments in this week.